Hello everyone, welcome back to my channel Shraddha's Physics. Today we will start with Cauchy's integral formula. In the last classes we have discussed about the Cauchy's integral theorem and some problems related to Cauchy's integral theorem. Now today we will see what is Cauchy's integral formula. Now let us see what is Cauchy's integral formula. Let f of z be analytic, interior to and on a simple closed contour C, then at any interior point z naught, f of z naught will be equal to 1 by 2 pi I integration over the closed contour C f of z divided by z minus z naught dz. So, we are going to prove this. Now, let us consider any closed contour, suppose this is C, okay, this is my closed contour and it is C, and the region inside it we are defining this region as R. This is the region R. The function f of z, the function that we are defining here, that is f of z, here we are considering that this function f of z is analytic throughout this contour C. Now, let us consider a point z naught, suppose this is the point z naught, here we are defining this point in some region R which lies inside this closed contour C. Now, this f of z divided by z minus z naught, here this f of z divided by z minus z naught, it is analytic throughout this region R, but except at z equal to z naught, if I will put z equal to z naught, then this function goes to infinity, this total term goes to infinity. So, here we can see that we can say that at the point z equal to z naught, the function will be not analytic, or function can be analytic at every point except at z equal to z naught. Okay. Now, let us draw a small circle. Suppose here I am drawing a small circle. This is suppose C1, this is suppose C1, this is the another contour, and we can say that the region between C and C1, this region between C and C1, here we can say that this region is called the multiply connected region. This multiply connected region, it can be converted to the simply connected region by drawing small cross cut. This is suppose small cross cut, or these are the parallel lines joining the contour C and C1. So, now this multiply connected region can be converted to the simply connected region. Now, you can see, first of all, see, when there are two different regions, this is C and C1, the region between C and C1 means this part, these portions are called the multiply connected region. Okay. Here, if I will draw two parallel lines or the cross cuts, if I am drawing two cross cuts to join C1 with C, then what will happen? You can see here, if I will start from this C1 point, I will start from here, then here, then after crossing through this, I will reach at the second cross cut, and through this again I will reach at the initial point, that is C1, or with the C1 contour I will reach. I will reach at the C1 contour. So, you can see that here the multiply connected region can be converted to the simply connected region. If I write the integration for this, suppose I am writing here the integration for f of z, z minus z naught dz. Okay, I have to integrate this. This is for first C contour, this one for this total C contour, then plus for this one suppose one path, this is suppose second path. So, similarly for first path I have to write f of z divided by z minus z naught dz, plus for the second path f of z divided by z minus z naught dz, and again the last one, the integration over C1 f of z divided by z minus z naught dz will be equal to 0 according to the Cauchy's integral theorem. Cauchy's integral theorem states that if the function is analytic on the contour and inside that contour, then the integration value will be 0. So, here you can see that if I will add this all, then this will goes to 0, because I have here converted this multiply connected region to the simply connected region. Here we can see that the integration sign the direction of this line 1, it is in the direction this is in the direction of suppose east, and in case of 2 it is in the opposite direction. So, this is in the suppose this is in the west direction. So, this will be the negative of 2. I can write this 2 integration as the opposite sign. So, it can be written as the negative of 1. I can write this integration as negative of the integration 1, and since these two paths are similar and I can say that these are parallel in nature and having the same length. So, these two terms since opposite in nature, so these two value will be opposite and they will get cancelled because one term is positive and other is negative. And here for the closed contour C, the direction will be towards the left hand side, and in case of C1 it is on the right hand direction. So, these two are in the opposite direction. So, I can change only one. If f of z minus z0 dz over the closed contour C will be positive, then for C1 I am taking it as negative and that will be equal to 0. Since these are not same in area, so I cannot cancel these two. So, now I can write this as, if I will take this negative sign total term to the right hand side, then this will becomes, if I will neglect all this, I can write here, this will be C1 f of z divided by z minus z0 dz. Clear? It means that this closed contour, the value that we will get for the closed contour C will be same as that of the closed contour C1 integration. Okay. Now, I think this will be clear to you. Now, we are going to solve this equation so that we will get the left hand side term. Clear? Now, let us consider this z minus z0 point, z minus z0 modulus suppose equal to r. Here we have considered this. So, that, or we can write it as, that implies z minus z0, or we can write it as equal to r exponential iota into theta. Suppose here we have considered that z minus z0 will be equal to r exponential I theta. So, that z will be equal to, what I can write, z0 plus r exponential I theta. Clear? Plus r exponential I theta. And again dz will be equal to, the value of dz will be equal to, since z0 is your constant, so the constant differentiation will goes to 0. So, this will be iota into r, the derivative of exponential I theta will be equal to iota r exponential I theta here again and d theta. Okay. Up to this much we know the integration over C f of z divided by z minus z0 dz equal to the integration over C1, this is your closed contour, C1 f of z divided by z minus z0 dz. So, let us consider this as, suppose this is our capital I, this integration value suppose capital I. So, in place of this f of z divided by z minus z0, in place of z minus z0 I have to substitute this value, and also in place of dz I have to write I r exponential I theta into d theta. Suppose this is equation number 1 and this is suppose equation number 2. Now, we are going to put equation 2, and this is also, these are both combining, I am writing as equation 2. If I will put the equation 2 in equation 1, then this will be equal to integration over, whether you should write C or C1, the same. So, this will be f of z divided by z minus z0 is r. In place of dz I am writing iota r exponential I theta into d theta. Okay. Now, this r get cancelled. In place of f of z, let me write z0 plus iota r e power I theta. Let me write here. This will be f of, in place of z I am writing z0 plus r exponential iota theta. Okay. Exponential, this is iota theta. Clear? If I will consider the radius to be 0, then in the function value will goes to f of z0, because if I will put r equal to 0, then this will f of z naught will remain into iota exponential I theta d theta, and the theta value varies from 0 to 2 pi. Clear? Z minus z naught is your r exponential I theta. So exponential I theta also here in place of this z minus z naught equal to r exponential I theta. So here I have substituted this value. So here I can write this is f of z naught iota into d theta. Okay. Now this will be equal to, here taking iota common and f of z naught common. So the remaining will be the integration over d theta over the limit 0 to 2 pi. So the integration over d theta is theta, and putting the limit 2 pi minus 0 will be 2 pi. So this will be 2 pi I into f of z naught. So here you can see that what we observe that the value of I, this value of I is equal to 2 pi I f of z naught, and we can write this expression as, here we can write this as, this iota means f of z divided by z minus z naught into dz. So if you will compare this equation, or you will see, I am writing this expression again. This f of z, this is the value of iota, sorry, this is the value of capital I. So this will be f of z divided by z minus z naught integration over the closed contour, whether you write C or C1, into dz, that will be equal to, here what we get, 2 pi iota into f of z naught. Okay. Now in place of f of z we can write, or this can be written as f of z naught will be equal to, this will be taking this 2 pi I on the left hand side, this will becomes 1 by 2 pi I, this is 1 by 2 pi I into integration over f of z divided by z minus z naught into dz. Clear? Whether the integration over C or C1, it doesn't matter. Actually, what Cauchy's integral formula imply? So it means that when this z naught point, it lies inside this closed contour, this z naught point, it lies inside the closed contour, then the value will be, value means f of z divided by z minus z naught dz integration into 1 by 2 pi I, this will be f of z naught. And if this z naught point, it lies exterior to the contour C, then in that case the integration value will be 0. So let me write this. So 1 by 2 pi I integration over f of z divided by z minus z naught, this is your closed contour C, dz, this will be equal to, one value will be f of z naught when z naught is, if z naught is exterior to C, if this is exterior to C, and the value will goes to 0 if this z naught point is interior, sorry, this value will be, if this is interior to C, this is interior to C, when the function lies within the contour, the value exists, that is f of z naught, and if it lies outside the contour, then that is, if this value will be 0 if z naught is exterior to C. Okay, it is exterior to C. Clear? This is interior to C. Here I am writing this clearly. So this value will be equal to f of z naught when z naught is interior to the contour, and the value will be equal to 0 if this z naught point is exterior to C. So we concluded that f of z naught, the value of z naught, the function value will be equal to 1 by 2 pi I integration over the contour f of z divided by z minus z naught into dz. If I will take the first derivative of this function, that is f prime of z naught, then this will be equal to 1 by 2 pi I into integration over the contour f of z divided by z minus z naught whole square into dz. Okay. And similarly, if I will take the second derivative of z naught, then this will be equal to 2 factorial divided by 2 pi I integration over the closed contour C f of z divided by z minus z naught whole power 3 into dz, and so on and so on. If I will take the nth derivative, for the nth derivative this will be equal to n factorial divided by 2 pi I integration over the contour C f of z divided by z minus z naught power, you can see that here the second derivative, so this will be 2 plus 1, that's why this will be n plus 1th derivative, sorry, n plus 1th power into dz. Clear? In the next class we will see how this Cauchy's integral formula will help to solve some integration. Okay, so this is all for today. If you have any doubt, can ask me in the comment section. Thank you all.